Now, step 18 is just a twist on what we just did. That was a nice, simple group by, right? It really wasn't that complex. We grouped by one of the players in the act, right? We had patient and appointments uh, joined together with a dot include, right? But in many cases, when you start summarizing data, you get into much more complex SQL, right? Or select processes, okay? LINQ is possible to do an outer join, left join, right join, whatever, right? It is possible, but believe me, it gets really ugly on the screen, okay? We did actually in my PowerPoint when we went through LINQ, I did show you how you could do one there, but it's not exactly straightforward stuff. Most of it that has a background in SQL will find it much easier to do that kind of coding in SQL itself, right? Okay. When you have multiple grouping levels, okay, outer joins, subqueries, and so on, wouldn't it be nice if we could actually just create that view in SQL, giving us exactly the data we need and pull it in? Well, yes, that's exactly what we're going to do next. So we're going to use a view, a database view, to supply read-only data, but we're also going to pull it into using a view model just to make our life a little bit easier on the receiving end as well. Again, for this example, we'll just get it up visibly on a view, but you could actually put it out into Excel very easily as well. Just a couple notes about working with database views then, right? Obviously, you have to supply the SQL, right, to create the view as an object in the database. So far, we've only ever created tables, okay, which come from our entity models. We did add some raw SQL. We use that to create some triggers for our blob for concurrency control. So using the same approach, we'll be able to create an actual view itself as an object inside the database, right? But how do we get our DbContext to work with that? Because it's not the same as a table. It's a different situation. But fortunately, our DbContext knows how to do it as long as we tell it that that's the kind of animal it's working with. So in the DbContext, first thing you do is we do add a DbSet for what? For the view model, right? It's not a regular entity model, but it is still a model, and we can create a DbSet for it. But to make sure the DbContext properly understands that it's working with something different here, it's not a table, what we have to do is go into the Fluent API in on-model creating, okay, and tell the model builder that this entity, giving it the name of our view model, right, relates to a view, right? And we give it the name of the view inside the database. Now there's two situations. Unlike a table, which should always have a key, a primary key, views don't have to, right? So if we don't have a key, a primary key, then we say dot has no key, right? Most often we usually still will. And if we do, then it's important to identify which one it is with dot has key, and then we pass in the name of the actual property that is the key. Now this will be a property of the view model, right? The key would be a property of the view model. Okay, so that's just some general code talking about how you go about doing this. Okay, and then obviously we need to actually supply the SQL to create the view, right? Doing code first development, okay, we can do that in one of a couple ways. So far we've seen two put into practice. Sometimes in our extra migration steps, we've added code like this, where we use the migration builder, okay, to execute some SQL. So it could be create view, la da 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 da. Or an alternate way we've seen is right in our initializer class, we can define a string, okay, that is the command to create the view, and then go to our context, database, execute SQL raw. We've used both of these in the past. Now in the medical office example, I've only ever used this one, but in our catering management, we've used both, right? So either one, as long as it is created, you're good. Okay, so that's it. We need the view model. We need to then add the code in the Fluent API, the DbSet and the Fluent API in our DbContext, and create the view. Once we have that in place, then we can just treat it like anything else, a simple query, right? The DbSet name, whatever we gave it, okay? We'd usually add as no tracking because it's obviously going to be read-only data to list it, and that gives you the data. And just as we talked about with database views, they don't allow an order by clause in a view. Well, but we have, once we have the data in our LINQ query, we can add our wheres, our order bys, and so on and so forth, right? Okay, so first of all, as a basic example, we're going to redo the one we just did, right back in step 17, okay? We did our group by with aggregates using LINQ. Again, remember, this is just a copy of the same code that we had. This is the group by that we used, basically grouping by the patient, pulling out the appointments, okay, counting how many appointments there were per patient, and so on and so forth, right? Where we're just going to replicate this functionality, but this time using a database view. That'll be our first little task here. Okay, so what do I have to do? Well, I have to first of all then go in. We actually have the view model. Yay, that's right, that's done already for us, right? We already created the view model, so we have that in place. So what I'm going to do next is go to the DbContext, because for the database, for the entity framework through the DbContext to work with our view, we actually have to work with the DbContext and tell it about the database view itself. So that will be, we didn't need the DbSet when we were just using it after our own LINQ query pulled the actual data. But now, because we're going to access it from the database view, we have to create the DbSet. So it'll look like this. Notice it's the exact same name. We created this in step 17, appointment summary view model, right? I'm going to call the DbSet appointment summaries, just a pluralization of summary. And then down here in on model creating in our Fluent API, we'll add that code like what I showed you, okay, to make sure the DbSet was aware that we can access this view inside the database and pull the data in to our actual view model, collection of our view model objects, right, our DbSet. Okay, so entity, the type is our view model. To view, that's the name of the actual view in the database and the name of our DbSet, both, right? Has key is ID, okay? So the ID in this case is going to be the ID of the actual patient. Okay, now we have to make sure we create the view in the database. So far in my medical office example, I've always been doing that in one place here in our extra migration steps, okay? So I'll put the code in place here, right along with the others. So I'll just copy and paste it in. So here it is, right? We're creating a view very much the same, okay, as what we did in our LINQ, okay? So creating a view, appointment summaries as, so we're selecting, okay, from our patient table, ID, first name, middle name, last name, our count star of number of appointments, sum of the extra fees as total extra fees, our max extra fee as max fee charged, right? And notice that these match, these names here with the as's match the properties in the actual view model as well, right? From patients, P, join appointments A on, right? The ID matches the foreign key patient ID. And there finally is our group by clause. Remember, that was our basically the same properties we had in the group defined, the key of the group defined in our LINQ query. Okay, so I'll just make sure I delete the database because I want to make sure everything runs and we migrate properly and so on and so forth. So that's the simplest way for you to make sure that happens. Now I could put it in the initializer class as well, but I just need it in one of the two and this should take care of it. Okay, so that next time I run that should get it in place and everything will be copacetic. Let's come back to our code for the actual action result now. So that's in the report controller right here, appointment summary. So basically this LINQ query, we won't need anymore. I'm going to comment it out. I won't delete it just yet, right? Just for comparison, you know, I really could almost go appointment summaries dot as no tracking to list, right? But, you know, I might as well break it out with a bit of an order by as well, okay? Just to give it some sense of order, pun intended, right? So I just go to appointment summaries because that's the name of our DbSet, right? That works with the view in the database, adding the order by last name, then by first name, right? And then all my paging code is in place and should do everything just as it did in the past. But just we're getting the data instead of pulling it all in to a LINQ query, we're getting it from the actual view inside the database. Will we see any different? We shouldn't. If I do see anything that looks different, it's probably that I made a mistake. There we go. All right, so yeah, we're getting all the data brought in. The only difference is how we're getting it in here, right? It's coming from the actual view inside the database itself. Well, that was a pretty straightforward example because this wasn't a terribly complex query. So let's do one that's a little bit more challenging, okay? apologize. I paused the recording there for a second to sneeze, and then I forgot to start it recording again. So I'm not gonna undo all the code changes. I'm just gonna walk through them if you'll bear with me. So, so we finished that first example, which was certainly educational, but the point was it wasn't a very difficult LINQ query, right? This, sorry. Anyway, I'll bring it up in Visual Studio. Right, that was let me get the report controller. Right, that was this one here. Right, so we did that, and then we turned it into a view, and that was okay. So, right, so we did it first with LINQ, but it wasn't a very difficult group by. We did turn it into a view in the database, and we ran it that way, which was an improvement in a number of ways, but it wasn't really that challenging. We really didn't have to go to the step of creating a database view. This next one, as I say here, is definitely a more complex example, right? So what we're going to do here then is consider something that really would be a challenge to do just with LINQ itself, right? The idea is that for summary purposes, the user wants some additional feedback. They want a list of all the appointment reasons in the system, along with statistics on each one. Basically, how often the reason was given for having an appointment, okay? So the number of appointments where this was the reason for it, the average age of the patients coming for those appointments, and just because we're doing aggregates, a total of the extra fees charged and the maximum extra fee charged, right? That's really not as important, but hey, I had to show something, right? So these are all the things that we're going to return. Okay, now the kicker here was we must include all the reasons that might be given for an appointment, even if there are no appointments in the system that reference that reason. In other words, as we know from our work with queries before, that's going to require an outer join. Okay, it could be left or right join. That just changes depending on whether you mention the first table first or the second table first, right? Okay. Now as I said, it's possible to do outer joins in LINQ, but it gets to be very, very messy. So instead, we're going to take the approach of doing it as a database view instead, right? So we do need a new view model object instead of appointment summary. This is appointment reason summary view model. Okay, so let me bring this over. You can see it better highlighted here in code itself. Okay, now it does have an ID which will function as a primary key. It's the ID of the reason. Okay, and we're going to pull in the name of the reason, the number of appointments, the average age, total extra fees, and maximum fee charged. But of course, using a view model has the advantage that we get our nice data annotations, which really come in helpful for display names if we're going to actually show this in a view and so on. Nice formatting, data type currency, things like that, even for our age here, specifying 2 decimal places and so on, right? So we get that in place. And then as we saw in our last example, some work has to be done in our medical office context. We need to add the DbSet, okay, for our view model, right? So pluralizing gives me appointment reason summaries, right? So down here in the Fluent API, I'll use the model builder to create for the entity appointment reason summary, that view model class, to view, right? And the name of the view has to match this for it to work, appointment reason summary. So that's going to be the name of the view created in the database, noting it has a key, the ID itself. Okay, now how do we get that in place? Well, once more, we use our extra migration approach because that's what I've been doing so far. Equivalent approach could be to put it in the medical office initializer, but I've been doing this, so I'm going to continue, right? So here is the actual SQL. Now, don't, looks a little weird, I know. Now, one of the differences is we're working with SQLite, and SQLite does do things a little bit differently from time to time from even our experience with SQL Server. Let me bring you back to our Blackboard course for a second. I have put up here in content categories, down in tips and tricks, a bit of a reference here for SQLite, concatenate, and other tips, right? For one thing, a difference you'll find is you start working with the code creating, see, so far, Entity Framework has done all the work of writing the SQL for us, but now we're going to be doing some of our own. So you can use the references available that I gave you earlier for SQLite, but here's a few common things. Concatenating, right? We use a double pipe, and that's how we do concatenation. No plus sign, no concat function, right? Just a double pipe. Okay. Just a note here, you can't have spaces in property names. It's not allowed, but we can use an underscore character, right? Uh, okay. Anyway, all right, so here's the one that we have to do. Difference in date or date calculations, things like age and so on. So I've given you a link here to a quick little article on different ways. Now, it doesn't have to be age, right? It could be any other difference in date in the same approach. So this is an okay approach here. Basically, you convert the dates to floating point numbers and just subtract. So the string from time, okay? So basically, we specify, do we want what components? Year, month, day, and so on, right? With a decimal point there. So it'll be years, and then the month, day contributing to a fraction of a year, basically. So this subtraction between the now time and the date of birth is pretty accurate for giving you the actual age. But you know, down further here, you'll find this one, and this is what I prefer because it is basically a replication of the approach that you might have noticed I use when we calculate age as a summary property in all of our model classes so far. Notice we're just calculating the difference in years, right? Mathematically, 1 year subtracted from the other year. And then that's accurate as long as you're past, right? The actual day, the month and day of the birth date in the current year. So that's what this is doing. We're taking the month and day, right? Converting that string from time. And then if that's less than, okay, the one for birth date, then it means we haven't reached the birthday in the current year. In that case, this will return 1, and we subtract 1 from the difference in years. So it's very much the same logic we've done in the past, right? Just want to share that there's some tips and tricks here on working with SQLite. Okay, so coming back to, that's what you see in here, right? So I'm casting this as an integer, and we're doing the average, and away we go. That gives us our average age. The rest of it is pretty straightforward. If null, right, that's how SQLite works. You pass it the value and then provide what you're going to use instead if it is null, right? So that gives us all of our values in this actual SQL query itself. So we're going to create that inside the database as part of our other steps in our extra migration steps. All right. Now, something else I did that was recorded, but I had it paused, is I decided I had a lot of migrations in here, so I started fresh, okay? Remember what that involves. I delete the whole migrations folder, came down, deleted the actual database, right? Use our common commands here. So I just executed this whole command to recreate the migration, okay? Then before updating the database, add your extra migration steps at the end, and you'll see that I have that in here, right? If I come into the actual migration, right down at the bottom, right before we actually finish the up and start the down, way down here, there we go. I call extra migration steps. And that actually then, when I update the database and it executes this migration, it will actually do that. Okay, then I can update the database and away I go. Make sure this is there when you update the database. Otherwise, see, if you update it once and it sees the migration has been applied, it doesn't know about these extra steps and it will just skip over everything, right? So I have to do that, or you can always just delete the database and have it recreated. That's a way to get around that. So we've done that. So we have that in place. So we have all of our data in there for the actual creation of the uh, view inside the database itself. All right. And everything is in the DbContext, so we're ready to actually start using it, right? So coming back to the report controller, what we added next was this bit of code here, appointment reason summary. Notice I set it up right from the get-go to expect that we're going to be doing paging, okay? And look at how simple our query is, right? Because we can take advantage of now we have our DbContext here, so I can go context dot appointment reason summaries, right? And that will actually communicate with the view inside the database, pull the data, then I can do my order by clause. If I just want to order it by the reason name, that's fine. The rest of the code is standard boilerplate stuff for our paging. Notice we pass our query here to our paginated list to get 1 page of data at a time. And that's it. So what I did when I wasn't recording is I right-clicked, we added the view, right? So here is the view itself, coming down to views, inside report, okay? Oh, sorry, wrong one. Here's our appointment reason summary, right? So this is pretty much as it was scaffolded, except of course I changed the name here at the top a little bit, and I added a form around it just so we can actually have the paging, Okay, add the paging nav bar just before the end of the form. Other thing I did is, of course, I took out the column with the normal links for edit, details, and delete. And of course, I also took out the create link at the top. Other than that, it's just as it was scaffolded by the entity framework itself. Okay, all right, so that basically is it. Of course, the final step was to add another link to our layout, right? So give me the option to select this report. And that's it. So let's just run it and see it in action. I'll take a moment here because it's creating the database. I had it deleted, seeding the data, and then it should be up and ready to go. Okay, so if I come down to that appointment reason summary, here we are. So summarize for each reason for appointments, how many I've had. So look at that. More appointments than anything else for just straight illness, followed by accident. Okay. COVID-19, well, that's actually other than 0 here. We've had 0 for work injury. Other than that, COVID-19's been the lowest. So that might be information you can see how that could be helpful to the actual medical office. Okay. Average patient age, not getting much variety, but that can happen because I'm just randomizing data, right? It could be if I extended the range of allowed birth dates that I'm generating, I could have more variety here. But anyway, don't worry. It's just seed data anyway, so it's really not meaningful. But you can see how with real data, this could actually be very useful information for the medical office. They might see that, whenever we have people coming in for an actual annual checkup, maybe it's the older population, right? Things like that. Okay, not much value in the fees, but hey, we're just doing aggregate, so we're practicing. Now, do I even need paging? Well, I only have these 6 values, but wait. Remember what we did earlier? If I come to my maintain lookup values, now of course I only have those 6 because that's all I seeded. But if I do this once again, right? Upload that data. There we go. Then if I come back, run my report once more. All right, so you see now I have 5 pages of data. Now, of course, most of this, there's no corresponding appointments for all these additional reasons I just added. That's exactly the behavior you would expect, right? But you can see it's actually working. That helps to illustrate that the outer join is functioning properly and that I'm actually seeing results for every reason for appointment, whether or not there was one or not. Okay, so that finishes our demonstration, pulling data from a nice, reasonably complex view that we created inside the database itself and using it to generate our information on the screen. Obviously, what I could do is on that view, I might just stick a button in the upper right corner or something like that to click a button and then download the same data into an Excel spreadsheet if that's what I actually wanted to do as an alternate option, right? Just maybe stick it up here somewhere so you can get this data into Excel as well. Okay.